Okay, so notice we're given some random function. This is not a specific function, but it's a random function, g of x, and there's a couple clues there. Hang on. Can you guys see that okay?
Yeah.
All right. Okay, so notice I give you a couple adjectives. It says purple here because my printer printed it out black and white, but on the editable Google Doc there, I have it in purple. So there are 3 adjectives up there. So the function is increasing from -1 to 6. Now remember, whenever you're given interval notation, these are x values. So on the x-axis between -1 and 6, the function is going uphill, okay? And this right here is just an ordered pair of -1, -4, and this is an ordered pair at 6, 3, okay? So this is in function notation. This is a ordered pair. So draw a possible sketch that depicts the purple adjectives above. Notice it says sketch here, so I'm just going to draw a rough sketch. So there's an ordered pair at -1, 4. So -1 and -4 is here. And at 6, 3. So here's 6, and here's up here at 3. Now what we do know is that the function is going uphill. It's increasing from here to here. So we don't know what it looks like, but it is going uphill. That's all we really care about. Now what's happening on the outside of the function, we don't know. We don't know if it goes back up or continues goes down, but what we have here is a snapshot between -1 and 6. All we know about this function, g of x, is that it goes uphill from there to there. So there's a possible sketch. What's happening on the extremities of the graph, it's irrelevant in this situation. So here is my little starting point here. Okay. Now, what I do want you to be familiar with is what happens to a function when you do these transformations. So I'm going to go over these very, very quickly because I'm assuming you did the Desmos activity with the marble slides and you did the 2.5 Excel. So you have a pretty general idea that whenever you subtract a function to the outside, it moves the graph down 3 units. This is going to move the graph up 3 units. So whenever you're affecting the output of the function, the outside, that's the outside of the function, that's the outside of the function, it moves the graph north and south. Okay, -3 moves down, +3 moves up. Okay. Now, if you're affecting the inside of the function, like this one here, this is affecting the inside. Okay. Here you would actually subtract 3 from the function, or subtract 3 from the x value, then put it into the function g. Here you would take g of x first and then subtract the 3. So the order of these things are very, very different. If you're affecting the inside, inside is related to the x coordinate or the east and west. And this is actually opposite. This is going to move the graph 3 units to the right. This is going to move the graph 3 units to the left. Now we have to be careful here. Q-E dot O. Q-E dot O. Because intuitively, +3 on the x-axis is that away. It's to the right. -3 on the x-axis moves that away. But since you're affecting the input of the function here, we have to be careful. It's actually opposite. So this is the only one that's not intuitive. -3 like a thermometer, yeah, moves down. +3 like a thermometer, the heat goes up. But when you're affecting the inside, everything is opposite. That's what the exclamation point means. Questions, concerns, comments? Okie dokie. Now let's talk about the negatives here. If you have a negative on the inside, what it's going to do is it's going to flip the function flip over x-axis. So it's going to make the function flip-flop over the x-axis like a book. No, over the y-axis, excuse me. This should be y. So flip over the y-axis like a book. So it's going to flip it that way. Okay. If you have a negative on the outside, it's going to flip over x-axis. Okay. The green and the pink are translations. You're sliding the graph north, east, south, and west. Okay. The pink and the green transformations slide the graph north, east, south, west. The orange or the negatives are going to reflect or flip the graph over an axis. All right, now people in period 1 yesterday, I had emails from people in period 1, and people were emailing me and just said, can you go over that again? And I said, go over what again? They said, what you did yesterday. I said, well, I talked for about half an hour. Which part are you talking about? So if you're, this may be the most intense you guys need to listen to a math Zoom meeting or a Google Meets meeting. If you're casually watching this and then you're on Discord or YouTube or doing something else, you may miss something, okay? So just a little word of warning here, word of caution to actively participate and have maybe some a pencil in your hand and take some notes, okay? But if you do need help, you can email me and say, can you go over that again? And we'll go from there. Alrighty. So we have subtracting from the outside, adding to the outside, subtracting from the inside, adding to the inside, and then we have negatives which flip the function. Now, what about a multiplier? Okay, this is going to stretch vertically. It's going to stretch the function up vertically. It's going to make the function grow 3 times bigger in the y direction. So think of it like bubble gum that you're taking and you're stretching the function vertically, okay? If the number is less than 1, 1/3 is less than 1, what's going to happen is it's going to compress or smush smush the function, okay? So let me relate this to something more specific like a parabola. So if we have, this is x squared here. Here is x squared. That is a specific function. 1/3 x squared would actually make the branches go wider. It's going to compress it or smush it. So that's 1/3 x squared. Okay. So it's going to make the y values grow 1/3 slower. It's going to make believe that someone is smushing the pink function down to get the purple. The 3x squared, okay, the 3x squared would make the function grow 3 times faster. So the orange would be 3x squared. Okay. And what that does is it vertically stretches the function to go 3 times faster. So on x squared, if you plug in 2, you get 4. But on this function here, if you plug in 2, you're going to get 12. So notice there was no change in the x, but there was a change in the y of 3 times bigger than 4. How am I doing, kids?
Great.
Good.
Nice.
Yeah? Okay, because
Amazing.
my self-esteem is very low. I need this affirmation. I'm very, very insecure. I'm very, very fragile.
Daisy, why are you laughing at that?
Yeah.
I'm sorry to hear that, Mr. Cash.
Yeah. Okay.
No, we just
be like
root
that.
for you, Mr. Cash. Don't worry. You're doing great.
Okay. Thanks. All right.
I hear sarcasm.
Oh, it is sarcastic. I'm actually a very prideful jerk. Okay, here we go. So let's go back to a g of x minus 3. So if this thing moved, okay, if this thing right here, give me just a second here. So let's talk about what happens to this function. If this thing takes the elevator down 3 units, this point is going to move down 3 units. This point's going to move down 3 units. If I slide this function down, like look, if I move it down 3 units, isn't it still increasing? It's just going uphill. So this is going to stay, it's just going to stay the same. It's still going to be increasing from -1 to 6 because it only took the elevator down 3 units. The x values didn't move. It just slid down, but it's still going uphill. Even if the function takes the elevator up 3 units, it's also going to stay the same for the same argument. Okay, so whether the function takes the elevator up or goes down, the interval of increasing will still stay exactly the same. Now, let's consider if the function got moved to the right 3 units. So if I take this function and let's say this thing was like a piece of pipe cleaner, okay, and I were to slide it that way 3 units, the -1 is going to go to 2 and the 6 is going to go to 9. I can visualize that slide. It's just going to move over. All right, it's going to go here 3 units. Okay, so this point here would move 3 units to the right. I'm going to call that A. This would be A ticky mark. And if we call this B, this would be B ticky mark. Okay, so if it got moved 3 units to the right, the y value did not change, only the x, because it's sliding to the right. So in this case, the first point, it's going to increase. It's going to increase from, let's see, the -1 is going to go to 2 and the 6 is going to go to 9. So it's still increasing, but the x coordinates, all I have to do is add 3 to the -1 to get 2, add 3 to the 6 to get 9. So I'm going to find the other function that moved to the left and do the same exact process. So this one right here, if the original point is -1 and it got moved to the left, okay, I'm not going to draw it each time. I'm just showing you guys this to show you what's going on in my head. And when you guys do your homework, if you're having trouble with this, draw the little function over again to help you visualize what's going on. And you could say, hey, there's only a change in the x coordinate, not the y. So you only change the x coordinate. So if this thing got moved to the left, the -1 would go to -4, and the 6 is going to go to 3. And it's also going to increase. Now let's get to the fun stuff here. Let's do the reflections here. Okay, so I'm going to flip the function over the y-axis. So I'm going to, if I fold this over the y-axis like a book, okay, what's going to happen is point B is going to flip all the way over here to -6 and 3. I'm going to call this B double ticky, so I keep track of what I'm doing here. And this A value, this A point, is actually going to move from -1, -4. It's going to move to +1, -4. Okay. and it's now going to go that way. So it's not a perfect reflection here, but if I fold this over the y-axis, what's happening is point B is going to move all the way over here, and point A is going to move all the way over here. So, hey, Leah. Marsh, sorry, I called you by your sister's name.
Oh,
Kate.
hi.
Hi. I'm sorry to call you by your sister's name.
It's okay.
I'm still stuck in 2019 where things were normal and happy.
You're good.
Kate Marsh, okay. Oh, boy. All right, so Kate, when we reflect this over the y-axis, what changed, the x values or the y values?
The x values,
Yeah, only the x value. What happened to the x value?
they became negative.
Just became negative, so the signs change. So, and then notice that the green function is going downhill, right? So
Yeah.
in this case, instead of it increasing, it's going to decrease. And the positive 6 became a negative 6, and the negative 1 became a positive 1. So the x values flip-flopped. So it's decreasing. Okay, now let's flip this thing over the x-axis. So if I take my original function and now I flip it up, like this way. The b value is going to go from 6, 3. It's going to move down all the way down here to 6, negative 3. 6, negative 3. And this point is going to reflect up to negative 1, positive 4. Down like that. Okay. So when I reflect it over the x-axis, the b point goes down here, the a point goes up here. Okay. So in this case, the y values changed, but not the x. Okay, and if you just kind of go through this argument here and go, oh yeah, the x value is still at 6 and 6, but the y values change on this one. And notice that the blue curve is also going downhill. So this guy here is going to decrease from negative 1 and 6. Notice the x values are exactly the same, only the y values changed. The x value stayed the same. What changed was instead of the function increasing, it's now decreasing. All right, let's talk about the vertically stretched. Okay, so multiply by 3. Let's look at the original piece of bubble gum here. Now, if I take the ends of this, if this were a piece of bubble gum and I stretch it 3 times bigger, I'm going off the page here, I'm stretching it. This B point is going to grow instead of 3 times 3 moves going to move this guy all the way up here to 9. 6 comma 9. Okay. So this thing gets stretched up to 9. I don't want to go further off the page, so I'm just approximating. And this point here is at negative 4. Charlene, are you there, kiddo?
Yeah.
Hey, this point here, the y value is at negative 4. If we stretch that 3 times bigger than that, how far down on the y-axis is it going to go?
Negative 12.
All the way down here at negative 12, exactly. So this point here is going to move all the way down to negative 12. And what happens is this function here gets stretched like bubble gum, okay? And I even chose pink like bubblegum flavor. Look at there. This is an omen. So it got stretched 3 times bigger. Notice the x values did not change, but the y values changed. Okay? So because there's a vertical stretch, it's still going to increase from the same exact interval. Because just because it got stretched vertically, it does not affect how wide out it goes. The hill now is just much more steep. It's 3 times steeper than this one here. So by a factor of 3, it makes the y values grow 3 times faster, but the function's still increasing from -1 to 6. Same thing with the compression here. If you have a factor of 1/3, what it's going to do is it's going to smush it. Smush. So we're going to take this guy here and we're going to smush it vertically down this way. So it's a little baby hill. So this thing gets smushed. So just because it got smushed, it's still going to increase from -1 to 6. So the increasing is going to stay the same. Okay. Questions, concerns, comments before I move on to the endpoints? All right, so let's talk about what happens to the endpoints. And what I mean by the endpoints is I'm referring to the original points here, this fat point here, and this fat point here. Okay, so the first one is down 3 units. The x values do not change. Everything moves down 3 units. So all I have to do is affect the y values. So this is going to move from -1 and 6. The x values didn't change. But what happens is the y values change. So this -4 is going to move down to -7. And this 3 value here is going to move down to 0. Okay, so even though the interval of the x values stays the same, see -1 to 6, -1 to 6, that stays the same. It's still increasing. But what happens to the endpoints is this B point here is going to move down. It's going to be sitting on the x-axis at 6, 0 because it got moved down. It took the elevator down 3 units. So the reason why I want you to know the transformations in a general sense is that you can visualize what's happening to the function, and therefore you can change the x or the y values accordingly. So let's go to the up 3. I'm going to do the same exact thing, except the thing got moved up 3 units. So -1 and 6 stays the same. All I have to do is I'm going to add 3 to the original points. The -4 gets moved up to -1. And Mr. Mayfield, what happens to the y value on this point here? Mr. Mayfield, are you there?
Sorry, I was muted. So you're talking about this. You're talking about this box right here. The y value, you add 3 to it.
So what would that be total?
That would be. I'm seeing right here. It's 6.
Cool. Thank you. All right. So let's go to this one here. This is going to be a change in the x direction because it's moving to the right. So if I take this point here and I move it to the right 3 units, the 6 is going to go to a 9, and the -1 is going to move to a 2 because I moved it 3 units to the right. The y values don't change. So in this case, let's see here, the y values don't change. So I'm going to keep that in there. Notice that it's increasing now from -2 to 9. Those are the values that I use. So everything's kind of lining up here. So the -1 goes to 2, and the 6 goes to a 9. All right, things are lining up here. Let's go to the vertical shift to the left. We're almost done, kiddos. Hang in there. So the -1, if we go to the left 3 units from there, we get it -4. And 3 units to the left of 6 would put us at 3. Now let's talk about the reflection ones here. So I'm going to go to my graph again. If I flip this thing over the y-axis here, notice that only the x values change. they change sign actually. So the positive 6 goes to a negative 6, and the negative 1 goes to a positive 1. The y values stay the same. So flip over y-axis. All I'm going to do is I'm going to flip the signs of the x. So this is at 1, negative 4, and negative 6, comma 3. And here, this is a flip over the x-axis, so we're flipping up and down. Notice my hand is changing, not left to right, but it's moving north and south, which is the y value. So all I have to do is affect or change the y value from a negative 1 to a positive 4, and the positive 6 to a negative 3. Yeah, right here. So flipping over the x-axis, and if I have to go back to my training wheels here, flipping over the x-axis, it moves it up. So negative 1, negative 4 to negative 1, positive 4. A change in the y when we reflect over the x-axis. This gets reflected down. Now the stretchy. Since we're stretching vertically, that's a change in the y direction. Everything got moved 3 times bigger. So the y value of 3 got moved to a y value of 9. So all I'm going to do is I'm going to take the y values here, and I'm going to multiply by 3. Okay, that's for my vertical stretch. So negative 1 and negative 12 and 6 comma and 9. That's these two. Now, just because this is a 1/3 and the thing got smushed, it's going to be 1/3 the value of the y values. So in this case, the first point is a negative 1, negative 4. So I'm going to smush that by 1/3. So we get negative 4/3. And the other point is 6 comma 1/3 of 3 is a 1. Okay, so on the original function, the original graph, we had point A and point B here. And what the 1/3 does is it smushes it. So it's kind of like this. It got smushed. So
Mr. Cash.
Yeah.
Can you slide your paper to the left a little bit?
Sure.
Because I can't see the coordinate. A little bit more to the left.
To the left, this way?
Yes.
Okay. So this guy right here, this little point here is negative 4/3. So it got smushed. It's still increasing over the same x interval from negative 1 to 6, but the end points got affected in the y direction. So what you're going to do